Problem when we are in front of a powder, ground coffee, how can we do? We develop a system which is quantitative, not on the sequences shows before, but new sequences which are in chloroplasts. Arabica and Canephora have different DNA in the chloroplast, and Alberto Pallavicini developed this test, which is a quantitative test. And you can see the first one, there is Arabica, only Arabica. The second slide, there is only Robusta. And the third one is a mixture of Arabica Robusta. For the moment, the test works up to a mixture of 10% of one species and 90% of the other, but we are confident we will manage to improve this test, go down to 5%, hopefully less. Okay, the species identification, we put in a patent both on that and both on the variety identification. So they are covered by patents. Coming down to Arabica, we can also identify the different varieties. And this is going to have a very heavy effect on the market, because as has been mentioned previously, now you can certify a specific variety of coffee, and as I mentioned, the prices can be really very, very different. The tools, the molecular tools, are the microsatellites. We were the first in the world to develop microsatellite in coffee. We developed something like 300 different microsatellites. Out of this, we isolated about 30 microsatellites, which are very informative, and we use these to identify different varieties. To give you an example, this is the, again, Alberto Pallavicini was on holiday at the Azore. With great surprise, he saw there was a cultivation, not more than one, some cultivation of coffee. Now, the latitude of the Azore corresponds more or less to the south of Italy, Calabria, correspond to Calabria. In Calabria, coffee doesn't grow, but the Azore apparently could grow. So he took a sample, brought it back to our lab. We analyzed the microsatellite and turned it out to be really Arabica, not only Arabica, but was variety Mundo Novo, so was coming presumably from Brazil. So the method is really powerful, and here is a genealogical tree of the different varieties. We analyze our microsatellites, so we analyze different pieces of DNA of coffee, and then we put together those which are more similar. And so with that, we constructed a sort of a genealogical tree where we have on the top, we have Robusta as out of Arabica, and then compared to all the rest. And so the closer are the, where is the, okay. These two here, for instance, means they are very similar. But if I compare this one with that green, there is very, very different. So the longer the branches, the higher the difference between the different varieties. Okay, now we constructed on the basis of genetic diversity this genealogical tree, with great surprise for us, we discovered that they collected according to their geographical origin. So all the black Arab Americans The yellow are derived, are interspecific crosses, so that they are diffused all over the world. With the hybrido de Timor, he's a hybrid coming from the island Timor. Then there are the Indian, also collected more or less in the same place. And the really great surprise was the Ethiopia coffee. Ethiopia coffee, you see, it is covering more than half of this tree, and the great variety, each plant is different from the other. So we cannot talk about a variety of Ethiopia coffee. It's a mixture of many different types of trees, which are very different one from the other. Now this allows, all this is in a data bank, of course, and can be consulted. What is the practical use of this result? Is that we can check the level of blend Arabica and Robusta, but we can also certify the origin. If I sell a certified coffee, which can be traced all along the line, of course, should cost more. So should give an advantage to the coffee dealers and to the producer. But there are some other practical use, like for instance the correspondence between a sample of coffee. If I'm a coffee dealer, I have a sample of coffee, I say, oh, this is a very good coffee, I'm going to buy 300 bags, then I have no tool to establish that there is a correspondence between the 300 bags and the sample. But now we can certify and say, yes, there is a correspondence. Okay, this is the group working on coffee. On the back we have our greenhouse with our coffee plants. And our data are stored in coffee DNA. And this is a flower of coffee in our greenhouse. Thank you.
Thank you very much. I've been told that some students would like to make some questions to Professor Graziosi. We have a very tight time schedule for the symposium, but we have found a small room outside here where you can go now, if you want, together with Professor Graziosi to continue informally